Hi everyone, this is Zoe from Seneca and today we're going to be talking about metals and metallic bonding. So, metals bond in a different way to non-metals. Cool. In a metal, the valence electrons delocalize and can move about the entire material. This is referred to as a sea of free electrons. Metallic bonding is often seen as a sea of free electrons surrounding positive ion cores. The positive ion cores are attracted to the free electrons. You can think of this as free electrons. They're a bit like a glue, holding the positive ion cores together. Metals are good electrical conductors because the free electrons can move and carry current. A general term for moving particles which can carry current is charge carriers. The melting point of a metal is related to its group. A group 2 metal will donate 2 electrons to the sea of free electrons. This means that the positive ion carries a 2 plus charge. The 2 plus charge has a stronger attraction to the free electrons. This means the melting point is higher. For example, sodium melts at 98 degrees Celsius, but magnesium melts at 650 Celsius. Imagine the heat. Metallic bonding is seen as viewed as a sea of free or delocalized electrons surrounding positive ion cores. The ions are attracted to the electrons. Okay, why are metals good electrical conductors? Because the free electrons act as charge carriers. So, metallic lattices isn't a word that I've ever heard of. All metals, when solid, display their atoms in a giant metallic lattice. Atoms are arranged in regular rows, held in place through electrostatic attraction between the positive metal ions and their delocalized electrons. Rows are able to slide over each other, giving metals their characteristic ability to bend and to be beaten into shape, also known as malleable. Metals have a high level of attraction between the metal ions and the electrons. This makes metals have high melting and boiling points. Metals with more delocalized electrons tend to have higher melting and higher boiling points. Metals have delocalized electrons. This means they are free to move within a metal's lattice structure. The movement of free electrons allows electricity to be conducted by metals. Metals have a strong attraction between the positive metal ions and the negative electrons. The strength of these attractions means metals do not dissolve easily. Okay, which of the following are true about metals? So, the more electrons that delocalize, the higher the melting point. They are good electrical conductors, and the free electrons act as a glue to bind to the positive ions. Okay, so now on to the optical properties of metals. Light is carried in particles called photons. Photons are not able to travel through giant metallic lattice structures because each photon carrying light bounces off the sea of delocalized electrons in the lattice. Some photons are absorbed, but photons are generally reflected from giant metallic lattice structures. The reflection of photons is why metals are often reflective or shiny. If a metal absorbs more photons, then it will be less shiny than a metal that reflects photons. Okay, that's all for today. Hope you enjoyed, and we will see you on the next episode. Goodbye.